G'day students, on this clip we're going to be going over two examples on the application of the law of sines and cosines. Alright, so let's take a look at question number one. So in question one, uh, it reads as follows. It says a footbridge is to be built across a small lake from a gazebo to a dock. Alright, so we're going to be building a bridge across this area right here from a gazebo to the dock. So let's go ahead and indicate the bridge. So from here to here is basically your bridge, okay? So this is a bridge that's going to be constructed bridge. All right, and this right here, this region is your lake, okay? All right, it says from a dock, from a tree 100 yards from the gazebo, the bearing is 24 degrees south from east. So the tree is 100 yards from the gazebo, so let's indicate that with a segment. So the tree is 100 yards, so let's put the measure there, 100 yards away from the gazebo. The bearing of the gazebo from the tree is 24 degrees south of east. Okay, so from a tree, the bearing of the gazebo is 24 degrees south of east. Okay, so how are we going to construct that? So let's go ahead and draw our four cardinal points. So there, here goes our four cardinal points. This is, we have north, south, east, and west. So the question is, how do we draw this? How do we draw 24 degrees south from east? So let's write it down. So east 24 degrees south. How do you draw this? So this basically, the east is where you start from, and this is the direction of rotation, and I mean this is the degree, and this is the direction of the rotation. Okay, so in this case, we're starting from the east. So we're going to be starting from this east, and then we're going to be rotating towards the south 24 degrees. Okay, so when you're starting from the east, you can either go northwards, which is counterclockwise, or southwards, which is clockwise. So since we're going in the south direction, we're going to be rotating 24 degrees in the clockwise direction. So it's going to look like a 24 degrees rotation down here, and it's going to be somewhere here. Okay. All right, so let's go ahead and draw that angular rotation here. So since we're starting from the east, well, let's draw our four cardinal points. So we have the north and south, and then we have our east and west going across. Okay, so north, south, east, and west have them intersecting at a point. All right, so starting from the east, we rotated 24 degrees 24 degrees towards the south. Okay, so this is the south right here. So if you rotate 24 degrees towards the south, this angular rotation right here, this is going to be 24 degrees. So the gazebo is 24 degrees south of east, starting from the east direction, okay, from the tree. All right, so there goes that. This is 24 degrees south. And then the next measure says from the tree to the dock, the bearing is 15 degrees east from the south. Okay, 15 degrees east from south. So in this direction, let's look at what the graph looks like for 15 degrees east of south. Let's draw four cardinal points again. So this is your north, south, east, and west. So where is south 15 degrees east, or 15 degrees south of east? I mean east of south. So remember the first cardinal point is your starting point. So we're starting facing the south, and then we can either rotate to the west or to the east. If we rotate to the west, that's going to be clockwise. To the east is counterclockwise. Okay, so starting from your south, we're rotating 15 degrees east or 15 degrees counterclockwise. So starting from here, our rotation is going to be in this direction. We're going to end up somewhere right here. Okay, so rotation is going to look like this. It's going to be in this direction right here. All right, and that will be 15 degrees. Okay, so let's go ahead and draw that here. So starting from the south, um, let's draw the segment connecting the tree and the dock, because this 15 degrees east from south is from the tree to the dock, okay? So we're going to put this angular measure right here. So this angular measure from here to here is going to be what? We start from the south and we're rotating 15 degrees in the direction of the east. So that's 15 degrees east from the south. All right, so there you have it. And then last, it says the bearing from the gazebo to the dock is 33 degrees west of south. Okay, so the bearing from the gazebo to the dock. So we're going to draw a four cardinal point on the gazebo, and we're going to graph 33 degrees west of south. All right, so let's draw our four cardinal points like that. All right, so now what does 33 degrees west of south, what does the graph look like? Let's go ahead and just sketch that on the side here. What does that look like? We're looking at, let's scroll up again, 33 degrees west of south. So let's write that down. 33 degrees west of south, from south. So since we're starting from the south, we're going to be facing downwards right here. Since that's your south, we have north, south, east, and west. If we go to the eastern direction, we're rotating counterclockwise. If we go to the east, east is counterclockwise, west is clockwise. So we're going 33 degrees in the west. Okay, so that means we're going to be rotating in this direction. So our terminal side is going to be somewhere here. And the angular rotation from the south is going to be 33 degrees. All right, so this angular rotation right here is 33 degrees. Okay, all right, so let's go ahead and graph that on the gazebo. So from the gazebo, we have, we're going to go 33 degrees west from south. So since we're starting from south, we're going to be rotating towards the west. How many degrees? 33 degrees. So this angular rotation right here uh, is going to be 33 degrees. So the question is, what is the length of the bridge? So how long is this distance right here? Okay, so to find that, how about we call this point, since it's tree, we'll call this point T, call this point right here G, call this point big D. All right, okay, now, if this is big T, that means the length of the bridge is going to be little t. This is big D. This is going to be, the 100 yard is going to be little d. Put a little d here. And so this is big G. This will be little g. Okay? All right. Now, we know that we have one side. Let's see if we can figure out the angles. Now, if you take a look at this angle right here, the angular separation between two cardinal points is 90 degrees. As you can see, it's a quadrant or a right angle. So this entire angle is 90 degrees. And if you take out 15 and 24 from it, what will be the measure of angle T? Angle T will be 180, will be 90 minus the sum of these two other angles right here. All right, so let's go ahead and do that computation. So angle T is going to be 90 minus the sum of these two other angles right here. 90 minus 15 plus 24. Okay, if we add those two together, we're going to have 90 minus 39. And then we're going to have 51 degrees. All right, 90 minus 39 is 51 degrees. All right, so angle T, the measure of angle T, which is this angle right here, is 51 degrees. All right, now we have one angle and a side. Let's see if we can figure out the measure of this angle right here, angle G. Okay, so to do that, let me erase this cardinal point from there. We don't actually need it. Make this slide a little bit longer. All right, so now let's see. If we know that if this is 33 degrees, this is a right angle right here. This entire angle is a right angle. Now, how many degrees are we going to have left in this piece right here? How many degrees is this going to be? If the whole thing is 90 and this is 33, then this piece right here is going to be 90 minus 33, right? So this angle will be 90 minus 33. Let's compute that. 90 minus 33 will give us what the measure of this angle here is. 90 minus 33 is 57 degrees. So this angle right here is going to be 57 degrees because 57 plus 33 is a right angle, which is 90 degrees. Now this is 57 degrees. How many degrees is this up here? Now since the east in the west are parallel. This line is parallel to this line. See, this is parallel to this. Uh, and we have a transversal connecting both of them. That means we have the formulation of alternate angles. Okay, this angle is alternate to this angle, and we know that if we have two parallel lines cut by a transversal, that the alternate angles, this is going to be alternate interior angles are going to be congruent. Okay, so since this is 24, this angle right here is also going to be 24 degrees. All right, because it's congruent to this angle up here as alternate interior angles. Now, this is 24 and this is 57. Now, what is the measure of this entire angle going to be? That will be the angle of the measure of angle G, right? So the measure of this entire angle, angle G, let's do that again. Measure of the entire angle, angle G, is going to be the sum of these two individual angles right here, all right? So angle G is going to be 24, which is this angle right here, plus 57, which is the difference of 90 and 33 down here. So we add those two together, we're going to get um, 81 degrees. All right, so angle G is going to be 81 degrees. So this angle right here is 81 degrees. Okay, so there you have it. All right, so we're going to be looking for t, little t, here. So in order for us to solve this triangle, how about we sketch this triangle again without all these marks on it. So we're just going to take the main measures that we know and see if we can figure out what we need, okay? All right, so let's sketch this triangle again. So we have a triangle looking like this. I'm going to label everything that we had previously. So we have a triangle looking like this. Um, this is, the dock is D. Well, that D, the tree is T, and the gazebo is G. Okay, so that makes this little G. So we have a little d as 100. All right, and then angle T is 51 degrees, and angle G is 81 degrees. All right, so now what can we do here? Um, can we Can we apply the law of sines or cosines? Well, let's identify what we're looking for. This is the length of the bridge. This is t. This is basically what we're looking for. So can we apply the law of sines or cosines here? We know that to use law of cosines, we need at least two sides, and law of sines, we need either SA or AAS. So in this scenario, we do not have a pair, neither do we have at least two sides. So we can't use law of sines or cosines. But since we have two angles here, then we can find the third angle using the triangle angle sum theorem. So we can find angle D. All right, so we're going to use the equation angle D equals 180 minus the sum of the other two angles, 51 plus 81. Okay, let's go ahead and compute that with our calculators. So we have 180 minus parenthesis 51 plus 81. And the answer is 48 degrees. So angle D is 48 degrees. Okay, so let's go ahead and put that here, 48 degrees. Now we have one pair, so it's sufficient for us to use the law of sines, okay, to find little t. So what we want to find here, we want to find little t. So to find little t, we're going to go t over sine big T equals, now the second ratio will be uh, the, uh, the pair that we know, okay? So we have little d over sine big D. Okay, let's substitute the values we know and find out what little t is. So we're going to have little t over sine big T is 51, equals little d, which is 100, over sine big D, which is 48. Okay, now to get little t by itself, we'll multiply both sides by sine 51. So sine 51 on the left, and then sine 51 on the right. Okay, so to find out the value of little t, We know down the left side is sine 51s cancel out. And then on the right, we're going to plug this into our calculators. Let's see what we get. We have 100 sine 51 divided by sine 48. All right, and the answer is, wait a minute, wrong mode. Let me change my mode to degrees. All right, let's try that again. 104.5753. Okay, so T is approximately 104.5753. All right, so what does this answer mean? Okay, so we have to write down what the answer means. It means that the length or the distance um, of the bridge from the dock to the gazebo is 104.5753. What's the unit here? It's going to be yards. Yards. Okay, so there goes our final answer. All right, so let's take a look at number two. Number two says a boat is sailing due east parallel to the shoreline at a speed of 20 miles per hour. So let's sketch our four cardinal points real quick so we can get a sense of our orientation. So we know that this is north, south, east, and west. So since the boat is sailing due east as indicated here, that means the direction of, of the boat is going to be in this direction. It's traveling due east. Okay? So it's traveling at 20 miles per hour due east. At a given time, the bearing of the lighthouse is 68 degrees east from south, and 30 minutes later, it is 52 degrees east from south. Find the distance from the boat to the lighthouse at boat position 2. So it's heading due east, so this is boat position 1. So this was its bearing to the lighthouse. So that means we're going to start from here and go to the lighthouse. And then 30 minutes later, it's right at this position, and this is his bearing to the lighthouse. Okay, so let's go ahead and construct our two bearings. First one we're gonna do is 68 degrees east from south. All right, so let's go ahead and draw our four cardinal points on position number 1. So let's go like that, and then like that. I am exaggerating my south and east because those are the two that are present here. Okay. So how do we find the bearing? So we have 68 degrees east of south. You're starting from the south direction. So starting from south, we're going to rotate towards the east, right? Because we know this is, let's draw this on the side first and resolve it so we don't get it mixed up. So let's draw it on the side here. This is south. So we're rotating in the eastward direction, which is going to be counterclockwise. So going towards the east. So we're going to rotate uh, 68 degrees in this direction. Okay. So what this is telling me is that this segment right here, if I rotate 68 degrees from the southern direction, that's going to take me right to the direction to the lighthouse. Okay, so this is south, and we're going to rotate 68 degrees towards the east. Okay, that's what this means. 68 degrees starting from the south. Okay, so starting from the south, rotate 68 degrees towards the east. So this is 68 degrees. All right, now on position, this is P1. On P2, we have a scenario where we're rotating 52 degrees east starting from south. Or starting from south, you rotate 52 degrees towards the east. Okay? So this one was south 68 degrees east. And now we're going to do for P2, south, starting from the south, we're going to go 52 degrees due east. All right? So what would that look like? It's going to look very similar to this. Let's just make a sketch down here before we graph it. So there goes your four cardinal points. If you start from south, you're going to rotate towards the east by a value of 52 degrees. So you're going to have something like this. This rotational angle right here will be 52 degrees. Okay, remember this is where you start. This is your angle of deviation. This is the direction that you deviate from where you started from. Okay, so it's going to be 52 degrees. So here we're going to draw our four cardinal points again. Uh, draw four cardinal points, exaggerating the two cardinal points that are indicated in the question, namely the south and the east. So there goes our this is the south right here, and this is the east. The bearing from the boat position 1 to the lighthouse is 52 degrees to the east, starting from the southern direction. Okay, so let's go ahead and draw that. All right, so it's gonna look. Let's draw the segment first and indicate the angle of rotation. So there goes the segment. Now the rotation that we did, we started from the south, and then we rotated 52 degrees. So this is going to be our angle of rotation right here, 52 degrees. All right, so now let's complete the whole shape. Let's draw our triangle. So from here to here, we have a triangle, and the question is, um, what is the look that up? Find the distance from the boat to the lighthouse. Find distance from the boat to the lighthouse at position number 2. Okay, so that's what we're going to find. All right, so let's go ahead and label our triangle. So let's call this point right here, since it's the first one, let's call it A, and let's call this point B, and then let's call this point C, okay? So if this is big A, this will be little a. The distance from position 2 to the lighthouse, this is what we're going to actually be looking for. This is going to be little c, and then this is going to be little b, all right? Okay, so let's go ahead and see if we can figure out some angular measures. Now, since this is 68 degrees, can we figure out the length of the value of angle A? Absolutely. These two angles are complementary, or they add up to uh, 90 degrees, okay? So the measure of angle A is going to be is a complement of 68 degrees, or 90 degrees minus 68. If we subtract those, we're going to have 10 minus 8 is 2. Left with 8 minus 6 is 2, so 22 degrees. So angle A is 22 degrees. Now, angle B is a combination of 52 degrees and this right angle right here, okay? So what is, this is 90 degrees, this is 52. So what is the measure of angle B? Angle B is going to be the combination of these two right here, okay? So angle B is going to be the right angle, 90 degrees, plus the bearing of both from position 1, position 2 to the lighthouse, which is 52 degrees. So we're just going to add them together, and our sum is going to be 142 degrees. Okay, so this entire angle, the measure of B is going to be 142 degrees. All right, now, can we figure out angle C? Absolutely. Since we have two angles, AA, we can figure out angle C using the triangle angle sum theorem. So we have angle C is going to be 180 minus the sum of the other two, 22 plus 142. Let's go ahead and compute that in our calculators real quick. So we're going to compute 180 minus 22 plus 142. All right. And our final answer is going to be 16 degrees. So the measure of angle C is 16 degrees. Okay. So we have AAA in this scenario. We have three angles. If we can get a side, then we can use law of sines, because we know AAS and SSA work for law of sines, okay? So let's see, can we figure out a side? We're given information about the movement of the boat. The movement of the boat is uh, 20 miles per hour in the east direction, and then 30 minutes of separation between position 1 and position 2. So how much distance did it travel for 30 minutes if it was traveling at a constant speed of 20 miles per hour? That is the question, okay? So what we're going to use here, since we have a constant speed problem, we're going to be using the formula, the dirt formula, distance equals rate times time, okay? So the distance covered in this case is going to be in hours, right? Miles per hour. So 20 miles per hour is the rate in hourly terms, times the time. The time is 30 minutes, but we have to be consistent with our units. Since this is in hours, 30 minutes equals half an hour. So the time we're going to multiply here is 1/2. Okay? So if you cover 20 miles in an hour, then in half an hour, you're going to cover half of that. So it's basically going to be 10 miles. 10 miles is the distance that the boat traveled within 30 minutes. So what does that mean? That means a little c is basically 10. All right? So there goes our triangle. So now we can try and figure out what the value of A is. Okay, so since we have um, AAS in this orientation, AAS, can we figure out the value of A? The question is, do we have a pair that we can use to figure out the value of A? And the answer is absolutely we can. Okay, so we're looking for A, so we find little a. So to find out, we're going to use the formula A over sine A equals, now which pair do we know? We know the C pair, right? Angle C, little c, and big C, we know what they are, so we're going to use C over sine big C. So that should help us solve this problem. Okay, let's substitute the values in. We're going to have A over sine A. A is 22 degrees equals little c is 10. We just computed that over sine big C, which is 16. Now to get A by itself, you multiply both sides by sine 22, and then this side by sine 22. This divides out, and then you have little a equals, plug that into our calculators and see what we get. Run calculator. Let's use the TI-83. So we have 10 sine 22 divided by sine 16. And then the answer is going to be 13.59. 13.5906. Okay, so the answer, letter A is going to be 13.5906. So 13.5906. All right, so what does this answer mean? The distance, let's write out the meaning of the answer. The distance um, of the boat from position 2 to the lighthouse, to the lighthouse is 13.5906. What's the unit here? Miles, I think it's miles. Yeah, 13.5906 miles. All right, so there you have it. So thank you so much for taking the time to watch this presentation. Feel free to subscribe to my channel by clicking up here, and you can click like if you liked this video. And please post a comment to tell me what you think about this presentation. More clips can be found on mathgutserve.com. Thanks again and have a wonderful day.